This is the Patreon-only release for the Grundig 3055/3056 multiband radio repair. So the version on the channel, I've severely cut it down and cut out a lot of stuff that I changed on it. We're going to show you guys the full uncut version. Check out this beauty. It's an old Grundig. It's got long wave, medium wave, and short wave bands on it. And we're going to do an overhaul on this one. Now, we're not plugging this thing in until we change out all of the bad caps because, well, you know that this one's going to be full of them. Let's take a look at the back of this one. Check out this beauty. It has 3 speakers on the back. I don't even know what the heck these things are. Those might be tweeters. It's got a couple of other things up here that look like they're square. I don't know what they are. They must be a speaker of some type. It's got a big woofer, couple side firing speakers, all tube construction. Check this out. It even has an antenna that you can rotate. From a knob on the front. You can adjust the direction of the ferrite antenna. What a beautiful piece of equipment this is, and I'm honored to be picked to service this one. This one came to me from a client, and you know that this is going to be a very well built unit. It's a Grundig, it's made in Germany. What else can I say? German engineering at its finest. So just to get our values of caps that we're going to have to change on this, I'm going to have to pull the chassis out on this to do that. And to do that, I'm going to actually have to disconnect the knobs on the front because they are connected to shafts that are connected to all this fine, all these dial cords, which I don't want to disturb them. I don't think they're broken at this point. I certainly don't want to break them. There's enough of them in here. In addition to the ferrite antenna, we've got a pre-selector tuner here. We've got our tune capacitor. It looks like we've got a pre-selector here to tune the front end. So there's a lot of dial strings on this here, so I really would rather not disturb them. So this is actually a separate tuning capacitor for a different wavelength. When you press the different band buttons on the front, it actually changes this clutching down here, which will then change the dial string or change the control to either tune this tuning capacitor or the main tuning capacitor on here. So it's quite a unique setup. Of course, whenever we work on a customer's piece of equipment, we always want to protect the finish. So I've got paper underneath here to do that. This unit here, I may not have to pull the chassis on because, as you can see, it has a hatch on the bottom. I should be able to get to all the capacitors I need to change without having to remove the chassis, which will save me a lot of work on this unit. Check this out. Okay. In addition to the flywheel on here to help you spin the dial faster, you got this other adjustment here, and as you notice, it's got strings attached to it. And if I turn the adjustment, you'll see that it actually pulls on slugs. You see, they're tuning the IF coils using a dial string. Incredible. We're going to change all the paper capacitors on this thing and the electrolytics. There's not a whole lot of them on here, as wouldn't be expected, because I'm not going to bother with all these little small signal ones. I don't think these ones are going to be an issue, but certainly these paper caps here, they all have to go. All the papers have to go on here, and the big electrolytic main filter, which is down here. It's just a dual 50 at 350 volts, so that has to be changed. And all of these other ones here, these ones all gotta go. We'll get those changed out on this thing. You guys couldn't see what I was pointing at there, off frame. Here we go. These paper ones here, these all have to get replaced. And the electrolytic. So we'll start by getting these ones. I have to get them. I don't have all the values I need in stock, so I'll have to go have to make a parts run. I'm going to take inventory. We'll get the parts, and we're going to swap these ones out and see what it does. See if we can get this thing working. I don't know what state this is in. I say I don't want to plug it in until I've changed all the paper and electrolytic capacitors on this thing, because just due to the age, they're bad. No question, they're bad, and we don't want to risk wrecking something else on it by plugging it in with a leaky cap. Check this out. It's an original Grundig rectifier. Rectifier. Gotta say that with the German accent, which I'm terrible at. Gotta pull this chassis out on this thing here, as I do need to get at some of the ones on the side here, which I've done. There's not a lot of clearance. The whole front comes out of this thing, right? But there's not a lot of clearance here because we do have wires and stuff that are, you know, attaching the speakers. But I can get this out enough so that I can get to these other caps on the side here to replace. Just finishing up my inventory. A couple more caps just as you can see down here of the power transformer and audio output transformers. This is the power transformer here. This one's obviously the audio output transformer. I'm just finishing up my inventory of capacitors that I need to go and get. And then we'll go get all the high voltage caps and start changing them and see if we can get this thing working. Be nice to get this thing. This is a real nice old piece of equipment. I've got one. This is not mine, but I have one sitting next to me here that I'm going to be working on. It's a Normandy. So everything that you see that's odd on this thing, the Normandy will be just as weird inside as this, guaranteed. Because all those European designs, you know, they were a little different than the American ones. I wouldn't say worse or better, just the way they lay things out different. I like this though. All these dial strings, they're actually metal. These are metal wires here. They've got, this one's got a cord on it. This one here is metal. This one here, let's say this one here is a regular cord. That one's metal. That one's metal. So it's a kind of a combination. It's like they use a piano wire for the main string, and then they use a cord to attach it. So, you know, this one here starts out. This one here starts out metal, and on the other side of the tension spring down here, it's conventional cord. I believe that's a big cap there. That's a multi-stage cap. I'm not able to see the value of it, so I'm going to have to actually remove it from the chassis in order to see. I get that. You can see the voltages and stuff here, right? But I can't see the value of it, so I've got to get this one out of here so I can get that one as well. Okay, this thing here actually is a selenium rectifier, and it's got to go. So I'm just trying to get it out of the chassis here. And the reason these things have to go is because these things, when they fail, they will release a toxic dust, toxic smoke. So we're going to replace this with a bridge rectifier. These are very old. Selenium was around before germanium and silicon had been invented, and this stuff is these are bad. So it was after rectifier tubes, but prior to silicon, they used selenium rectifiers, and that's what this is. So I'm just going to remove this thing and get rid of it, and we're going to replace it with something a little more modern. Okay, the first thing I'm going to replace on this is I'm going to replace that selenium that I took out of here. I'm going to replace it with just a full wave bridge rectifier. So I've got the two AC terminals down here. This is the positive terminal, and the negative goes over to the ground here. So I'm going to have to extend some of these wires a bit. Just going to mount it so that the AC terminals will connect easy to the output of the transformer, which is right here. And then I'll extend the positive wire and the negative wire to the respective points on the board, or on the chassis. Getting low on solder. I should have picked some of that up when I was at the shop yesterday. I'm going to turn on some more light so you can see what I'm doing here. So I've reattached the B plus wire here. I'm just going to bring this down and attach it to the rectifier, the positive terminal of the rectifier. And because this is going to have a high voltage on it, I'm going to put some heat shrink tubing around here just to prevent anything from touching it. I don't want to break this wire off again here. I already broke it once. This is the where it goes to the chassis. This is the positive lead that was coming out of the selenium rectifier. The problem with heat shrink tubing is if the wire heats up, the tubing will actually start to shrink before I get a chance to utilize it. So we kind of have to work with it here to get the heat shrink tubing in place now that the wire is cool, and then I can shrink it properly. There we go. Okay, that's got the primary wire out of place. Now I just have to dress it out of the way, and we'll get the negative connected to the chassis. Gonna use a piece of wire for that. I'll just pick a piece of bare wire, I guess, and we'll just ground that down to the chassis here. Maybe I'll pick a piece of black wire. Okay, this should take care of the ground wire. And that should be able to just sit there in free space and be okay. Now we can start changing capacitors on this unit. I'll start on the easy ones to get at here. This one here is a 2200, what is this one? 2200 picofarad, 1 kilovolt. So we're going to replace it with a little ceramic 2200 picofarad. This went in here. This went right across here. It'll end up sticking in there like that when it's done. I also have this other one back here. This is it also. What is this one here? This one looks like the same size. This one's also a 2200 picofarad. I believe this one's only rated at 500 volts, but 2200 picofarads, 500 volts. there's a second one. It's also 2200 picofarads. It's this one back here, and it goes from the same terminal that this one's on. It goes over to this one over here. So we're going to just cut this other one out. And put the new one in place of it. And then now I'll go up to this terminal up here. Okay, that's got those two replaced. Get them out of the way so they don't touch anything. It's kind of a silly way of supporting this. It just clips in place. But that now got the selenium rectifier replaced by a silicone rectifier. And get that so that it doesn't touch anything. Bend these components out of the way so nothing touches. And it doesn't touch any resistors that could get hot. There we go. Okay, that's got those components replaced. Make sure that the AC leads aren't too close together. There we go. Okay, that'll prevent that from touching anything. The wires aren't going to touch anything hot. They're not going to touch anything near ground. That's got those replaced. Sorry about the hum. I've got my 400 watt work light on here because most of the light on my bench is forward. Because I'm usually working on stuff on the bench, so all my lights are overhead or forward, so this part ends up being in the shadow. So I've got the big backlight on now so that I can see what I'm doing, and it really does give me good lighting in here. You really can't beat a 400 watt street light basically. I could probably service most of the rest of the capacitors in this unit. Look at this, it's even got a ground. When the bottom plate gets screwed on, this pinches against a foil piece that's on the bottom for shielding. And there's more, I don't know if that's in front of the antenna, I think that might be an antenna. There's more on top here, you can't see it. There's a foil, like a shield, but it's not continual. It's broken in the middle here. And you guys can't see it, but this wire connects to it. This looks like an antenna wire. And one side of this twin lead connects to this metal plate that's on this side, and the other side connects to the metal plate that's on this side, and it wraps down. You can see a bit of the edge of it right here, right across the top on this unit. I guess that's part of the antenna system for some of the bands that this thing's got. Anyway, let's start replacing parts. There's this electrolytic here that's got to go. And this is, where is it connected to? It's connected up to here, right up to here. And this one here is, it's a great big electrolytic, but it's actually, what is it? It's a 2 microfarad, 300 volt. So we've got some, what did I do with them? I know I've got some 2.2, I think. Pretty sure I got some 2.2 and 100 somewhere in here. Yeah, here we go, they're 400 volt. So here's some 2.2 at 400. And of course, when you know, of all the components, these ones here have got little short leads on them, like right out of the bag. 400 volt 2.2. Preformed leads. One side of it's grounded, and the other side goes up to here. So I'm just going to have to find a wire to ground this thing, but we'll connect the positive lead up to where this one goes here for starters, and then we'll have to get a piece of wire and connect it down to ground. I'm going to connect it to the back side of this terminal here that it's on. I also make use of the free terminals that have got holes in them already. Make use of those. It makes it just easier to attach components. We'll just form a little hook in the end of this cap. Just hook it in there. Can't quite get to the other part. Take it out. There it is. So there's the old one. Two microfarad. 350 to 385 volts. Look at the size of that thing. And it's been replaced by that little one. Just gotta find a piece of wire to connect that in now. I'm going to go in behind this other cap just because I have to change that. That'll be one of the next ones I probably change is that one. Just going to ground it to this resistor here. It's grounded already because it'd be easier to attach it to an existing component than it would be to heat up the big lug here with this little low-powered iron. I had a big 150 watt gun and it wouldn't be a problem, but it's easier just to attach it to a resistor that's already there. Okay, that solves that one. I'll do this 0.68 next. Gotta find it. Okay, using the scope, I've already determined which side has got the outside foil on it. That's going to go to this side that's grounded on here. Some of these caps will also say outside foil. Of course, this one doesn't seem to say anything. But I'm going to assume it's the side with the black band. So we'll take the original one out. Do it one terminal at a time. That makes it easy to see where it came out from. For those that are wondering, I'm actually heating up the binding terminal here, and I'm pushing the wire through the hole so that the component is attached solidly. I've got another one here. This is another 0.68. It's going to be the same as this one. Or I should say 0.068 is what this is. Just making sure there's sufficient isolation. I've got this other one back here to change too, which goes between this binding post and this one over here. That one can actually be mounted around the front, for that matter. Can't get at it to cut it. Impossible to get at. There we go. 0.022. And the negative will be to this one, the same as it is on this one. 0.022. Okay, after that one done, another one over here, 0.022, another one the same. Wonder why they look different. These are both 0.022. This one here, as well as one I just took out. But this one here is a dipped as opposed to a paper, but it's getting replaced anyway. And this one goes way over to this side over here. And they've got a piece of insulation tubing on there because it does cross over other components that could short out, so we're going to replace that tubing as well. Just cut the old side out here first if I can. That side's in. And the other side goes right over to here. Next one I'm going to change is this one over here. This is a 0.01. I know I've probably showed it before, but I'll show it again. These capacitors they're not polarized, but they do have a shield. And you want to have the side, your outside shield connected to whatever your lower impedance side is, such as your ground. And how we measure them is we put a scope probe across it. The side with the outside shield will act as an antenna and it will pick up noise from the air. Especially if I bring my hand close to it, okay? Right, this is the outside shield. I've already marked it, but you can see how much noise comes up. Now if I reverse the probes, the amount of noise is less. Right, there's the ambient noise. If I bring my hand near it, you can see the deflection on the scope. And if I reverse the ground and the tip, you see how much higher that is when I touch it or bring my hand near it. So this is acting as an antenna, picking up just noise out of the air through my body. When I put the ground side on there, it's less. So that's how you determine with the scope. The easy way of determining the side of the capacitor that's got the shield connected to it. So that's this one here. I tell you, restoring old radios is kind of fun. You do have to follow the safety procedures though for working on tube equipment, because vacuum tube equipment is very dangerous just due to the high voltages that are involved in all tube equipment. You're talking hundreds of volts, so you have to really be careful if you're working on a unit that is energized. This hasn't been energized in, you know, years. So there's no risk working on something that hasn't been plugged in. But if you're working on a unit that has recently had power, you really do need to take precautions to make sure that capacitors in it are discharged, because unlike solid state components that operate relatively low voltages, well, vacuum tubes, if they're not hot, if they haven't been heated up, they're not in conduction, and there's generally no way to bleed away that voltage that's built up inside a tube unless, or inside a capacitor, unless the tubes are in conduction. So beware that they can and will store a charge, and can store a charge for quite a long period of time. So you really need to take precautions before poking around inside any tube equipment that's recently had power applied to it. A chicken stick is a pretty good way to do things. Now, one thing you generally don't have to worry about in vacuum tube gear is causing secondary damage by grounding things out. In solid state, you don't want to start poking around a ground rod to discharge things, because you can pop components. In a tube set, that's not the case. Get yourself a nice insulated screwdriver, connect your ground clip to the screwdriver, connect one side to the chassis, and then you can go around with your screwdriver and you can touch all of the capacitors, especially the power capacitors, you know, just to make sure that they're all discharged. And you don't have to worry about damaging components on tube sets. That's why a lot of fighter aircraft still use vacuum tubes, believe it or not, in some of the servo controls for their, flight control. Because in the event of a nuclear war, if there was a nuclear detonation, all solid state devices would be rendered useless, and the aircraft flying would crash. So they use vacuum tubes still in a lot of them for that reason, so that they're just more reliable. They can withstand EMP and all kinds of abuse as long as you don't physically break the tube. They generally are pretty much indestructible. And they can short and so forth. The grids and stuff can come loose from vibration, but and overdriving and stuff. But generally, they are pretty immune to damage from surges. Let's just say you're not going to damage one by shorting out components. Okay, I got a couple more electrolytics I got to change here. A couple big honkers in here that are just huge, and they're going to be replaced with a little itty bitty capacitor. You guys probably can't see this one on camera because it's out of the angle of the lens, but there's a big one in here. Take this one down. This is going to a tube socket. And it goes to ground, and I'm sure I can pick up a ground a lot closer. But this is 100 microfarads, 12 to 15 volts. Look at the size of that monster. Electrolytic, so it's polarized. I have some here. 100 microfarad. There you go, 63 volt. Yeah, I'll do the job. Tell you, I'm intimidated when I see a big capacitor like this. see something like that, you think, oh, that's a high voltage device. No, 12 to 15 volts maximum. No danger there. It's going on to the bottom of the one of the, I think it's the output tube, the EL84. It's going to be, I think, probably in the maybe the cathode circuit. It's between ground and it just bypasses the resistor that also goes to ground. So this will be a really easy one to put in here because I don't have to take it all the way over to where it was to the ground, to the chassis. There's another ground right next to it, so I can just put this thing in here and get it out of the way. Yeah, I really enjoy working on these antique sets. It's I'm a kind of a radio buff myself, and I enjoy working on these tube sets because I never got the opportunity when I was in the electronic business, when I made my living fixing equipment. I never got that much of an opportunity to work on tube gear because the fellow that I worked for, he wouldn't allow it. It was, he didn't want to work on anything that had tubes in it. And he wouldn't allow stuff, he wouldn't allow console radios or any of these old radios to come in, no matter how much people wanted them fixed. The guy that I worked for just would not permit them to come into the shop. So even though I had training and so forth to do this stuff, because the shop that I actually learned at did a lot of tube stuff, the place I worked at for 20 years didn't do any of this stuff. So it's kind of fun to get back into looking at this old gear. Love it. It's just this old technology. It's so simple. You almost don't have to think. Just change parts. 10 microfarad. This was an 80 volt. Now I've got some here. 10 microfarad. Okay, that's that one. There's going to be some real fun ones to get at down here. You can just see there's a few of them here that are just kind of buried. But we're getting there. Okay, next we're going to do this little blue cap back here. This is another little bypass capacitor. It's going from ground to one of the tubes. So we'll just cut it out of here for now. Let's see what it is. Oops, I lost it. Not really, it just kind of fell down. It's right in here. So this one is a 0.022. Here's a 0.022. Again, we'll mark the foil side. I test everyone, even though all the ones from the same batch are all coming out the same. This one goes down here, it goes between ground and pin, it's like pin 1 of one of the tubes. Just trying to figure out the best way to mount this thing in here. It's a bypass capacitor, right? So put some insulator on one of the leads. Okay, that's one more done. We're slowly getting through these capacitors. There's not that many to change. I've got, I think I got 4 left on the underside of the chassis here. 5. So I have 5 left. And then I've got 1 or 2 more over here to do. There's not a lot of caps that have to be changed in these radios. They're, as I said before, they're pretty simple. So you just take your time and do them one at a time. And generally that's all you have to do with any of these old radios. You know, providing that the tubes and stuff are broken. If the glass isn't broken on the tubes, then it's a good chance the tubes are fine. It's just going to be these bypass caps that have gone bad, which are very common. So it's just a matter of replacing them. I'm just doing another test. Okay, this one's going to go in to replace this one right here. It's going to go in like that. I'm just going to see if I can move this camera down a bit. Just so hopefully you guys can see some of the other parts I've changed here. I don't know if I can get this thing any lower than this or not. I might be able to get it a bit lower. Bring the crane down a bit. Without having it in my way. Okay, so to go over the ones I've changed, now that we can see what I've done. Here's some of the ones I've changed so far. I've changed this one here, and these two, and this one. Electrolytic up here, electrolytic here, and this one behind here. That's been changed. I've still got this one over here, these two, that one there, and that one to change. And that should do it for the caps on the lower part of the chassis on this thing. So we're going to change this next one here. This camera's actually looking right over my shoulder right now. You can see that this one's had a hot part, like a resistor lead or something's been hot on that, and it's kind of deformed this capacitor. If you look at it, it's almost been melted over the years. Now I'm going to solder this onto this wire that's going to the ground here rather than the ground itself, just because my iron won't get that tab hot enough. So I just pick a wire that's going to the ground. I got to be careful here because I've got some dowel strings and stuff in the way here. I don't want to touch them or I'll burn them or melt them. There, that's got that cap in place. Okay, next is this other big one over here. And it goes down to this, it's one of the IF coupling caps. Or maybe a bypass. It's probably a bypass, it goes to ground. One side of it goes to ground there, the other side of it goes down to the first terminal of this transformer, the one that's got the yellow wire on it. This is a 0.1 at 250. I got a 0.1 at 630. I think we're probably okay with this. Marking the cap again. This is not so much for me, it's for the next person that might work on one of it, might work on this radio if it ever gets worked on again. Chances are if it ever gets worked on again, it'll be me that works on it, but just in case. If you wonder why the camera keeps getting bumped, it's because it's in my way. It's a little too close right now. We'll have to move it because it's just a little bit too close for comfort, and I can't get my hands in here to work. Think of the fun I could have had if I had filmed all my repairs when I was in the business. Man, I could have had thousands of videos up. But of course, way back then there was no YouTube, right? I don't think my old boss of the day would have appreciated. He wouldn't have appreciated filming videos anyway. Because we were all pretty secretive back then. We didn't want people to know what we did. We didn't want people to know how we made money. So once again, with the camera over my head so that I can actually work on this thing, I just wanted you guys to get a look at what I'm working on, where some of the stuff you couldn't see. But I think these ones, you'll be able to see these two caps that are coming out of here now. There's two of them. They're both going to ground. So we'll just cut the leads off a little bit with a little bit of length here so that I can tie them down to the original wires. And these both go down to a tube. One's below the other, so I'm going to do the lower of the two first, which is this bigger one here. So this one's a 0.022, and again, you can see that this one's just not in very good shape. It's all kind of getting deformed. So 0.022, it's 500 volt. Mine are 630, so I'm okay. 0.022, here it is. I think they're both the same. Both these are the same value. Yeah, they're both the same value. Just one's a little higher voltage than the other. But they're both going to be 630s that I replace. So I'll get the last two ones out here. For you guys wondering how bright it is in here, well, there's the lux meter. 5456 lux right here. This is from my this monster of a light behind me. It's makes it pretty bright in here. Like these are the last. Oh, there's one more. There's last three, and we'll be able to put power to this thing and watch for magic smoke. Once again, we'll check just to verify the polarity. They're all going to be the same. 9 millivolts in that direction. 23 millivolts in that. Yep. Yeah, they're the same. All the ones that have been out of this batch have all been the same. So we just mark them again. Do it the same way. I'm just looking at the digital voltmeter portion of the scope. 18 millivolts, not 20 millivolts. And we put it on this way here. 8 millivolts. Okay, so that's also the shield. I didn't even bother to look at the waveform. I just look at the RMS millivolt reading on the side of the scope. One with the lower, one is the side with the shield. When the ground is clipped onto this side, and the probe is clipped onto this side, the reading will be lower. If I reverse it and put the probe on this side and the ground on this side, the reading is higher because the shield, as I've explained before, the outside foil is connected to this side, and this is the side that goes to ground. Okay, this is going to be a fun one to get in here. Well, kind of a fun one. You can see where it goes. It goes right to the same lug that this big resistor is on. Ah, get in there. Crimp on. That's better. I'm trying to crimp the leads down so that they got something to solder to, right? So I'm crimping them down over top of the existing tube socket. You son of a... It moved. Goddamn. Let's do that again. Get in there, hook that up. There we go. That's better. Okay. .022. Jeez, I hope I got another one. .022, yep, got two more. And this one, like some of the other ones I've found, the opposite side is like the other ones I've had have been the side on the left side of the labeling has been the shield, but on this one it's the right side of the labeling. And the only way to tell that is to actually measure it. So you got to measure them, every one. Generally, if you have a bunch of caps in this from the same brand that are come in the same bag, they're out of the same batch, and generally you're okay. But for every specific value of capacitor, you have to measure every one of them just to make sure. This one's going across the terminals at the back here. Don't know what they're for. Could be an antenna terminal. That's what that's across. And then we can turn the chassis upright and get the last few ones that are on the top. So, oh, I've still got the electrolytics to do. Gotta do them too. They're on the bottom here. So I've still got these two big electrolytics that I'm going to put in here. So this big can here is I'm going to replace it with just a couple of caps that I pulled out of a switching power supply, primary filter for it. It's only 50 microfarads. I've got 68 here, so they will be fine. There's just two of them, so I'm just going to connect them up, and we'll cut the wires off the original one and just tie them down to these caps. So I'm just going to connect the two negatives together so that I can mount this thing. It's ugly, but you know what? It'll do the job. I'll leave the original can in place. I'll just disconnect it below the chassis. And that's normally what we do on these ones. Sometimes the guys like to take them apart and actually gut the capacitor out of it and then stuff a few new ones inside the can and make it look original. I don't quite bother with that. I think that's going a little bit overboard. For me, as long as they're electrically connected, they can sit in the bottom of the chassis. Nobody's ever going to see them. One's got one wire going to it. The other one's got two wires and a resistor that I have to connect. Probably the easiest way to deal with this is just to cut the lugs coming through the chassis here. That way I don't have to unsolder or anything. I can just cut the lugs and put the lugs right on the new caps. There's one. This one's hard to get at. There we go. That's the other one. There's one side tied down. I'll just move that out of the way. I still got to get a ground point here, but that's one side of the electrolytic in place. The other side will go to this wire here that I cut off from this other lug. Okay, that's that one. I just have to get a wire now to ground. The ground point is right down here, so I'm going to just grab a piece of wire. Oops. That wasn't supposed to break. Okay, I think we're grounded okay now. Nothing's touching anything. Our high voltage is all isolated. So the last cap on here that I need to change out is this one over here by the transformer. This is a this is hilarious. This is, well, I'll let you guys see what it is. It's stupid how big this thing is and how low it is in capacity. Made in Germany. It's a Grundig. It's made by Siemens. 20 microfarads, 35 to 40 volts. Minus 20 degrees to plus 70 degrees. That'd be Celsius. Positive on this side. It's going to get replaced with this little bloody thing here. 22 microfarads, 63 volts. And the leads might not even be quite long enough to put it in place here. Because the old one was so big. Looks like I could probably move this wire. This is just a binding post. There's a spare one over here. So I'm going to move the positive lead here. I'll move it over here to the spare binding post. That way the cap can fit in here without stretching the leads too much. Positive. Negative. Over here. I believe that has all the capacitors on this thing done now. And the rectifier. So now we'll put the chassis back in the box and we'll power this thing up and see whether it makes any noise or loses any smoke. And in case you guys are wondering, how do you center the chassis on something like this? Hang it over the edge of your bench, put the chassis in, you can actually look down and see the holes, and then from below you'll be able to see the screw coming up from below and screwing into the chassis. That'll hold it in place. Do the same thing for the other screw. Then I'm able to turn it up on its side or turn it around and just put the last two screws in. But this is the way to do this. I think one of my washers came off. I think that's the one that goes on this side. Remember I said that ground tab, it just gets trapped in between the base plate and this copper tab. That grounds the base and provides some shielding. I'm probably jinxing myself by putting everything back together before testing it. Okay, something like this, I'm only going to power this up. I'm always obviously going to go through my current limiting light bulb just in case there's a problem. That way we won't damage anything. So let's apply power to this thing. I don't even know how to turn this thing on. Base. Hayden, that must be treble. This one says B-A-S-S-E, I'm sure that's bass. This one says H-D-N-E-N, but it's got the treble clef. It's got the bass clef on this side. Kind of gives away the controls. So there's the tone controls here. It's got a bass control here, a treble control here, and looks like it's got a tuning eye over here as well. Or is that this one? I don't know where the power on this thing is. Maybe you just press the button to turn it on. That's volume, I'm guessing. And that is going to be tuning. Let's turn on the power. That's a good sign. My light bulb didn't light up real bright. It just came on momentarily. So my current limiting bulb is not showing that there's any shorts. I don't know what band I'm on.
That one back until Monday.
Obviously, that's the AM band because it's working.
Dimension is out in Maple Ridge. Hydro crews are currently working on Doobie Trunk Road at 256. They have it down to one lane in each direction.
Wow.
If there's anything else happening on the roads or on the highways, you know what to do. Colton Studio. Our phone number is pound 730.
So that's AM 730.
Now, here's the latest from the CKNW newsroom.
Mounties and Langley are
CKNW.
Where?
Doesn't tell me what frequency I'm on here. You know what? The lights aren't working. Ah! Okay, it's backwards. So you turn it to the left to go up.
No, it's...
There's my little transmitter running. Complete with all its hum because that's not grounded, right? And I'm not in a good place here in the shop for it. We know all about the hum, but...
And also,
how do you do,
Anissa Hetherington and Eddie Gregory back at TSN headquarters in downtown Vancouver. You know what we're going to tell you? Go do what you got to do. Light it up, rip it up. Hey, throw the bomb on third down. Just do us a favor. Be safe.
As the afternoon wore on, the harsh Canadian winter...
What is this frequency? I have no idea. Looks like this is short wave. It's got FM on it. Wow. There's my little transmitter here in the shop. There. Okay, I just noticed something here. It does have FM, but it only covers 87 to 100 megahertz. Right here it is here. Oh, you guys can't see that. Let me lower this down a bit. Okay, so you guys can see the band. So here's our bands down here. 87 to 100 megahertz, it goes backwards. Interesting, it won't turn down anymore now. Okay, what did that do? I don't know what these buttons do. So, it covers 87 to 100 megahertz FM. I don't know why it's got UKW1 and UKW2 because they both say the same thing. They both say 87 to 100, but only one seems to do anything. So I don't know why it has two buttons on it. The same. KW says 5.9 to 15.8 megahertz. You're going to need an antenna for that. I don't have an antenna on it. So I don't think we're going to hear anything. There's 10 megahertz there. That's this band down here. It's actually pulling something in. You know what? I think that's a harmonic from my little transmitter. It sounds like my music in my other room. I don't have an antenna on this thing, so I'm not expecting to pick anything up. It has the long wave band. Oh, here, okay, that's what comes on for long wave. That lights up. But what does it do? Long wave band lights up here. I don't see any meter or anything there, unless it's a magic eye tube and it's not working. That's long wave. Medium wave is your AM band.
Good status. Goodale asked for advance notice. Abbotsford, maybe hop off at Fraser Highway at 240th and take Robertson Crescent as well and try to avoid that. Or, you know what, even easily, or rather even better, just take the number 1 instead. Because unfortunately, it sounds like it's going to still be a little bit of a wait until that's all finally cleared up. So,
anyway, this thing's working. It's working great.
It's closed between Burrard and Howe. Good news is it reopens tomorrow morning at 6 o'clock. And
it also has a TA. I'm going to say that's a tape input. Or maybe it's a turntable. Ah, that's turntable. It's got a picture of a record with a needle. That's a tape input because, well, it looks like a tape. And OS, I'm going to say that's power off. OS! Total offs. Power off. Okay, so, hey, it works. I'm happy. The guy that owns this thing is going to be thrilled to get his old radio back working. His old Grundig. It's a 3D Klang? Fun. I don't even want to try to speak German. I shouldn't be trying to speak German. Lautstärke, that'd be loudness. Sender, Einstellung. Okay, anyway, hey, that's it. That's all she wrote. Restoration of an old Grundig 3055. Thanks for watching, and we'll catch you again real soon. Oh, I figured out what this is. It has two tuners. Right? It's got two presets. Right?
Do you think anyone wants to be bundled up?
That's what that's for. I couldn't figure out why it did that, but it's actually, when you press these buttons here, it actually changes the tuner. There's actually two separate tuners in here for the FM. So, and the medium wave. So you can preset two FM channels and see, when you're in the AM band, the dial will adjust all three of them at the same time, but in the UKW, which is your FM band 1, and UKW2, it actually physically changes to a separate tuning capacitor so that you can set two stations. So if I set one station here, right, and I go to the next one, now I press this one, and it goes back to the other station. Pretty cool. That is really cool considering the age of this thing. Here's a perfect demonstration here. Okay, I've got it on my little AM transmitter that hums so bad if the antenna's not pointed the right way. Remember I told you this thing had a directional antenna? Watch this. Turn the antenna internal. I'll turn this thing around so you guys can see that working. So here's the radio running, and if I just turn that adjustment, you'll see that it'll spin the antenna in the back here. So I can minimize the hum that I get from all the electronics in here. There you go. That's the inner workings of this thing. So here's one tuner here, and the FM tuners are over here, and there's going to be, I guess there's two of them. I didn't even look at this thing, but there's obviously two presets on this thing. So there's two separate tuning capacitors for FM. So when I've got it in, this is the number 2 position. You'll see that it's actually turning a capacitor in behind here. You don't see it, but it's underneath here. If I put it in number 1 position, it's going to turn this one. So that's, yeah, there it is. And that band switching is done through this little mechanism down here. You can see it. So this is where the mechanical switching is done, where it changes FM2 and FM1. Is that there's one underneath here and behind here, because when you press that FM1 band, you'll see the dial turning, you'll see the flywheel turning behind here, but nothing else moves. So there's another one in behind underneath here that I'm sure we saw it when the video was apart. I just wasn't paying attention to it. I didn't realize this thing had 3 separate tuning capacitors in it, but obviously it does. It has another one in behind here for the FM. It's going to be connected into this circuit here. This is the FM front end, so it's just going to be another tuning capacitor, but it's going to be underneath on this side here where we don't see it. Anyway, real neat machine. I've never seen one of these things, and has really good sound. Anyway, thanks for watching, guys. My Patreon users are seeing the full version of this video because I've cut it severely for the regular users. So if you want to see the full restoration, all the parts replaced on this thing and everything else on it, you'll have to be a Patreon. Thanks for watching. We'll catch you in the next one.